All right, we can go ahead and get started here. Thanks everyone for joining our webinar today with APSmart and CPS, where we'll be discussing our commercial PV rapid shutdown solution as part of our rapid shutdown webinar series. So just a little bit of housekeeping here. Everyone should see a bar on your screen, usually at the bottom, that has a button like the chat function. So the chat function will be used by the hosts and panelists to submit comments and links to related to the topics that we'll be discussing. And there's also the Q&A button there for anyone to submit questions throughout the webinar, as we'll have a Q&A session at the end. So my name is Anton Patton. I'm an applications engineer with CPS America, and I will be presenting today with Chris Barrett, the Senior Director of Training and FAE at AP Systems. So in today's webinar, we'll give a quick company intro to both Chint Power Systems and APSmart. Then we'll take a look at the background of rapid shutdown and the requirements that are now in effect for rooftop PV systems. APSmart is going to go over their rapid shutdown product. And I'll discuss the turnkey solutions that CPS offers for the C&I market. And at the end, we'll have some time to go over questions that you may have. So for those of you less familiar with Chint Power Systems or CPS America, CPS is a division of a larger, diverse energy company called the Chint Group. The Chint Group is a global, publicly traded company with over $9 billion in revenue and has been in operation for over 30 years. Here in North America, we focused on the three-phase string inverter market, but have now expanded to become an energy solutions provider for solar and storage projects. We've shipped over 4 gigawatts of UL-listed inverters in the US, with a market-leading #1 share in the C&I market, including our partner sales. Our team prides ourselves on being focused on service for our customers, from pre-sales and engineering support to logistics, order fulfillment, and service through the life of our products. And with that, I will pass it to Chris to give a little introduction to APSmart.
Hello, everyone, and thank you very much for joining the webinar today. Yeah, I just wanted to introduce the APSmart really quickly here. We are a global provider of module-level power electronic equipment for the solar industry. That includes rapid shutdown equipment for string inverters and also microinverter technology for worldwide business units, so located throughout the world, so also in the United States, Europe, Australia, and through Asia, and 9 other offices for sales and support. Manufacturing capabilities are both in China and now in Taiwan because of the tariff issues that we've been all facing. R&D centers throughout the world actually are mostly in Cupertino, so most of it's designed and all manufactured in Jiaxing, China, and just outside of Taipei in Taiwan. Serving more than 120 countries throughout the world again, but with local teams set up for support here in this country, with support teams located from the East Coast all the way to the West Coast, so open from 8 a.m. East Coast time to 5 p.m. Pacific. Next slide.
Great, thanks, Chris. So I'll start out with a little background on rapid shutdown. So some might be asking, what is this rapid shutdown and why do we need it? The rapid shutdown requirements are described in the National Electric Code, section 690.12, and apply to PV system circuits installed on or in buildings. The key goals of rapid shutdown are to reduce shock hazards and improve the safety of first responders to sites with solar PV. Rapid shutdown was introduced to provide a simple method for firefighters to de-energize the solar DC conductors and ensure safe conditions when they need to get up on the roof during a fire or emergency situation. Almost every state has adopted the additions of the National Electric Code that require rapid shutdown for PV systems installed on buildings. Here you can see a map showing the addition of the NEC that is in effect in each state. As of July 1st, 2020, there are 35 states that have adopted either the 2017 or 2020 edition of the National Electric Code, and 9 states that are still on the 2014 edition. And the different editions of the NEC have different requirements. So it's important to know what codes your solar PV project need to comply with. For more information on code adoption, it can be found on the NFPA website, and I will put the link to the website in the chat window for anyone that is interested. So you should see that there. And so today we're going to focus on the 2017 and 2020 editions of 690.12, which essentially require module level rapid shutdown. The 2017 and 2020 NEC call out a 1-foot boundary from the PV array, and all of the conductors outside of this 1-foot boundary must be limited to no more than 30 volts within 30 seconds of rapid shutdown initiation. Also, all the conductors inside this 1-foot boundary must be less than 80 volts within 30 seconds of rapid shutdown initiation. So since string inverters on their own are not able to meet 2017 or 2020 rapid shutdown requirements, module level power electronics must be used. And with that bit of background on rapid shutdown, I will pass it to Chris, who's going to go over the APSmart module level solution to meet these requirements.
Well, thank you so much once again. Well, let's dig into it. Next slide. Okay, well, again, this is just a little bit more of a background of AP Systems here, but founded in Silicon Valley in 2009, actually incorporated in 2010, so we just celebrated our 10-year anniversary. So very exciting there. Lots of installations throughout the world, so I won't bore you with all the details there. Profitable since 2012, so that is also a very, very nice thing as well. Certifications and technology patents, over 100 at this point right now. As you see from the picture below, as I talked about before, microinverter solutions, communication devices, online portals, and of course the APSmart DC series. Next slide, please. Okay, so let's dig into it. So the RSD actually itself is a small little clip-on device that goes onto the back side of the modules. As we talked about a second ago, it meets the NEC requirements for 2017, 2020, 690.12 for the module level shutdown. Again, that's very important, module level shutdown. So it's each and every module gets shut down individually using the Star NC device. Again, smallest device, again, you clip on or stick on, depending on the module you choose. If it has a frame, of course, it can be clipped on. If it's a bifacial without a frame or flameless, can be stuck on using the special tape. Reliability, again, this is everything that we do. It's all about reliability. We want to make sure that this thing is on this roof. It actually works fine, and it works fine for a long time to come. So we use proprietary equipment, definitely lots of design improvements and proprietary components in the PCB. Next page, please. Okay, as far as power consumption, we're saying less than 1 watt. So it doesn't take much actually to run it right here. Operating voltages, again, very low, 7.7 volts. Does this thing to actually come on and start working properly? And then we also say longer operation per day. So extra 30 minutes, probably 15 minutes in the morning, 15 minutes in the afternoon. because of that low startup voltage. One thing I want to talk about here is stability. And one of the things that we always talk about in this industry is stability and noise. What we don't want to do is have any kind of this, like we show down here, the RSD PLC noise is well below the waterline here. We don't want to have any kind of nuisance stripping with the AFCI breakers. Next slide. As far as size is concerned, again, we talked about this is very simple, very small. The input ranges from 8 to 80 volts. Maximum input current is 15 amps, so most modules today will not have that. Maximum power input, 550 watts. So again, we're meeting the requirements of today. System voltages. Now we can actually do 1,000 or 1,500 volts, which is a standard for the industry today. Standard operating temperatures, anywhere between 40 and 85. Again, meets the NEC 2017 and 2020. And that meets the EMC compliance. Now, one thing I do want to point out as well is all the RSD devices all are all connected with the MC4 connectors, the true MC4, not a copy or a compatible. Next slide, please. As far as the installation is concerned, we talked about that a bit, but this actually can be used as actually a bowl that can be attached to the device that can be clipped either on the inside or the outside of the module. And you can see right here, we're showing a couple different examples of front buckle method, a rear buckle method, and then also a little bit of wire management, depending on if you have the center tap modules or the standard J-box on the north side of the module. And the piece right here is the RSDI detector. This right here is a tool that we also sell as an installation and troubleshooting tool. This right here, this tool is able to give you the ability to monitor or create basically a pulse modulation in the device to be able to test when you're installing this device, you'll be able to see that pulse, keep a live signal, make sure that it's there. You can transmit and detect all with one device available from APSystem. Next slide, Jason. Jason.
Thanks, Chris. So as some of you may have heard, in June, Tygo issued a press release announcing that they were suing APSystems. So to date, Tygo has not actually served APSystems with any court documents. They simply announced publicly that they were suing APSystems and then nothing. So what we have seen regarding this suit is exactly what the public has seen, which is just a public declaration of a lawsuit with no substance behind it. So allow me to elucidate on that last point. So Sunspec, they established the rapid shutdown standard 3 years ago in July of 2017 as an open standard. They called it a multi-vendor communication interoperability specification to support NEC 2017. Tygo, from what we have heard, took issue with the open standard, claiming it infringes on their IP. They sued APSystems, or they announced that they were suing, and APSystems, who is a leader in manufacturing products that utilize the open standard with our APSmart brand. Sunspec has publicly stated that the open standard does not infringe on any IP, saying that Sunspec is convinced the Sunspec rapid shutdown specification to be sound and free of infringing material, as you can read there. Also listed there on the slide is a website you can go to see Sunspec's public statement about the open standard. So something that we continue to make clear to our customers and to the public at large is that an entire industry of rapid shutdown systems and devices developed over the last 3+ years currently follows this open standard. This applies to not just rapid shutdown devices, but inverters, PV modules, string combiners, other components that utilize and meet the standard. So apparently APSystems has been singled out by Tygo to be representative of this industry. But we, just like Sunspec, are confident that there is no IP infringement, and we will continue to vigorously defend our rights and those of our customers, as well as the open standard that we all use. So now I'd like to hand things over to Anton with CPS.
All right, thanks, Chris and Jason. So Now I'm going to go over the turnkey rapid shutdown solution with APSmart components offered by CPS for commercial PV projects. What our team at CPS has done is we've integrated the APSmart transmitter and core into our APS rapid shutdown wire boxes of our 25 kW, 50 kW, and 60 kW models so that no external components or enclosures are needed. So if you're looking at a rapid shutdown installation with these inverters with integrated wire boxes, you're basically connecting the DC conductors directly to the inverter and the AC conductors to the inverter as you would a typical commercial installation that does not have module level rapid shutdown components. So we've done a lot of work to make meeting rapid shutdown and installing those systems simple and easy. We've also optimized the wire boxes for NEC 2017 and 2020 code by removing the negative fuses, which allows more working space in the wire boxes for our customers. And for rooftop projects with 208 volt service interconnections, CPS will soon have our new 25 kW 208 volt inverter product. CPS has leveraged the hardware and form factor of our popular 50, 60 kW model to develop this 208 volt solution. This new model will be offered with an APS rapid shutdown wire box option. This inverter is currently going through UL certification, which is scheduled for completion next month. So if you have a 208 volt project you're working on and are interested, please reach out to our team about this new product. So looking at all the components of the rapid shutdown solution, you have the APS module level devices that are connected to each module in the array, and the strings connected to the inverter, and the inverter with the APS transmitter integrated into the wire box. So it's a simple, low cost, easy to install solution to meet rapid shutdown requirements. The rapid shutdown devices, transmitter, and inverter are all tested together as a UL listed PV rapid shutdown system when used with CPS 25, 50, and 60 kilowatt inverters. All of the components from the inverter with integrated rapid shutdown wire box, APS module level devices, and even modules can all be supplied and shipped by CPS. And CPS has worked closely with the APSmart engineering team to ensure the proper functionality of their products and our inverters as a rapid shutdown system. We've focused on qualifying simple, cost-effective solutions with rapid shutdown functions only and minimize components and complexity. In addition to certifying the rapid shutdown functionality of the solution, CPS performs further diligence and testing, both in our R&D lab and field testing, to confirm the compatibility and performance of the products when used together. CPS also provides technical support for the APS rapid shutdown solutions, as well as our inverters, to make sure there's no finger pointing if any issues in the system do occur. And one example project that has been installed and operating in the field with this solution is a 120 kilowatt system in Greensboro, North Carolina. This system has 365 modules, each with an APSmart RSD-SDS PLC device connected to them, and two CPS 60 kilowatt inverters that have the APS rapid shutdown wire box. And the feedback that we've received from customers has been positive both on the ease of installation as well as the system's operation and reliability. So to summarize, CPS can supply the complete solution for C&I rooftop projects, including APS devices, the inverters, modules, as well as data communications and controls solutions. And so CPS can be the one-stop shop for all equipment needed, and is able to ship all of the components together to the project site. And so if you have a rapid shutdown project that you're working on and need a solution, please reach out to our team. My contact information is below, as well as our sales team to support you. And with that, it looks like we do have time to open up for questions if there are any. And I want to thank everybody for joining the webinar today. Let me take a look at what questions have come in. So, one question. This is, it's like it's for the APS team. So, are there module manufacturers that the APS devices can be used with? I'll pass that to Chris.
Yes, thank you so much for the answer question. Yeah, it doesn't matter what the brand of module is, as long as it meets the electrical specifications for the device itself. So it is agnostic. Any brand module you would like.
Got it. Thanks, Chris. And then one other question. Do I need the RSD-I product for my installation?
RSD-I, yes, absolutely. So you will need the RSD-I. So the RSD-I, well, need is a good word. So I would recommend that every company would probably have one of those devices on hand. Like I said, it's a helpful setup tool to be able to verify that everything is installed and working properly. And also troubleshooting. If there's any kind of issues in the future, it's also nice to have that tool, because then you'll be able to send signals from that device and verify that each of the RSD are working properly. I recommend the tool. Yeah.
Thanks, Chris. Yeah, thanks for clarifying. I did get a question about getting a copy of the presentation. Forgot to mention that in our housekeeping. Yeah, so this webinar is recorded, and we can send an email with a copy of the PDF to attendees. Let's see, another question. Are the inverters CEC listed for installation in California? Yeah, so the inverters that we mentioned in this webinar, the 25 kW, 50 kW, and 60 kW inverters are all CEC listed to the latest Rule 21 Phase 2 and 3 requirements, which are needed for all interconnections with the IOUs in California. When will the first 208 volt inverters be shipping? So as I mentioned, the certification is currently in progress, and we're expecting that next month. So we should be able to ship the inverters starting next month, but please reach out to our sales team to confirm availability and get aligned on the schedule for your project. Let's see, I've got a question. What does it mean, what is meant by the communication between the transmitter and module units? You want to take that one, Chris?
Sure. Yeah, the means of communication is actually power line communication, or PLC. So it's actually pulse modulation from the transmitter through all the DC lines to the RSD units.
Got it. Yeah. So to add to that, it's PLC communication through the power line. So there's no other communication wires or equipment needed. You're basically connecting the DC home runs to the inverter DC input terminal, and all of the transmitter and core are already integrated in the wire box. So all of the communication is there. And Chris, I think you mentioned a little bit about the keep alive signal that the transmitter sends. So yeah, so basically when AC is lost at the inverter, that keep alive signal is lost, and the modules will all output 0.7 volts.
Yep, perfect.
All right, one question. What connectors are compatible with the RSD-S-PLC?
Okay, so exactly like I said, this is actually an MC4 product on the device itself. So not an MC4 compatible, not Amphenol, not some knockoff. It is a true MC4 from Staubel. Industry standard.
Right. So all of the units that we supply as a standard have the Staubel MC4 connectors. And so if your module has MC4, it's definitely compatible with those. I know a lot of modules have MC4 compatible, so definitely make sure you know that the module manufacturer is saying that those are compatible, or if you can get the MC4 connectors. Related to that, we got a question: are there any connector options other than Staubel MC4?
The answer is yes, but it would be a large volume purchase. So yeah, I mean, we can crimp on whatever connector you know the customer wants. But again, it's a more of a volume. So, and again, it's up to CPS and what you guys want to do.
Right. I mean, as we mentioned, the MC4 is our standard and industry standard, as you know, the most common connector out there. But if there are specific projects that you know need a specific connector, or if there's an issue with using MC4, then definitely reach out to our team, and we should be able to work with you. Let's see. Got a question. Will the RSD-S-PLC work with the 600 volt, 100K, 125 kW CPS inverters? So, as I mentioned in the presentation, the PV rapid shutdown system certification has been done with the APS devices and our 25 kW, 50 and 60 kW inverters only. So with the 100, 125 kilowatt inverters, we have not gone through the testing and certification for that for a rapid shutdown. I will also mention that the 100 and 125 kW inverters are our 1500 volt DC products, which in the US, 1500 volt DC is not allowed on rooftops. So we have really focused on the 1000 volt inverters for the rapid shutdown solutions. Okay, I've got one. Have you ever seen any issues with PLC signal mixing when multiple DC strings are laid in the same raceway? Or do the strings of each inverter need to be physically separated? You want to answer that,
Yeah.
Chris?
Sure. So the strings that share the same transmitter do not need to be separated. So if they share the same transmitter, then there's no need to make those changes. But there's multiple transmitters on a site, then you wouldn't need to separate those. But typically, you're doing an array with one transmitter going down for an entire array. So this is not usually an issue in a raceway. That's a great question.
Great, thanks. So I guess to clarify, if there are multiple inverters with a transmitter each, you would want those DC connectors separated and not in the same raceway.
Right.
Right. Yeah. All right. Yeah. So it looks like we've got a few other questions, but probably more specific and can be answered in a conversation with our team at CPS and the customers. So we'll have some follow-ups with some of the attendees here, and if you do have any other questions, feel free to reach out to our team. Again, my contact information is here. If you would like to email me or our sales team if you have any projects you would like to get quotes or information for. All right, so I think we'll end it here. Thank you, everyone, for attending, and thank you, APS team, for hosting this webinar with us. And hope everyone is staying safe out there, and have a great day.